Case study: AI, ethics, and cybersecurity, navigating complex challenges in MedTech Solutions' response to a major DOS attack. A sophisticated cyber attack paralyzed MedTech Solutions, a leading healthcare provider, affecting thousands of patients and jeopardizing sensitive medical data. With the principles of cybersecurity confidentiality, integrity, availability, authenticity, and non-repudiation at stake, MedTech faced a crisis that required immediate and strategic action. This case study explores the multifaceted approach required to address such a cyber incident and the key lessons learned. MedTech Solutions, renowned for its integration of advanced AI in patient care, had invested heavily in state-of-the-art medical devices and an interconnected network infrastructure. This infrastructure simplified patient care but also expanded the attack surface for cyber threats. One morning, the IT team detected an unusual spike in network traffic. The traffic spike was indicative of a potential denial-of-service attack. What protocols should the IT team prioritize to mitigate the immediate threat while maintaining service availability for critical healthcare operations? Upon investigation, the team discovered that the attack was a sophisticated DOS assault overwhelming the system with malicious requests. The attack not only threatened the availability of medical services, but also raised concerns about potential breaches of sensitive patient data. Redundancy and load balancing mechanisms were employed to distribute the network load and ensure system resilience. These strategies were essential in maintaining service availability, highlighting how critical such measures are in protecting against DOS attacks. While the DOS attack was being mitigated, another issue emerged: unauthorized access to patient records. This raised a significant concern regarding the confidentiality of sensitive health information. How can MedTech reinforce its data confidentiality measures to prevent unauthorized access during such an attack? The use of encryption and robust access control policies became paramount. The IT team ensured that all sensitive data in transmission and storage were encrypted, making it unreadable to unauthorized users. Access to critical systems was restricted to authorized personnel only, using multi-factor authentication to add an extra layer of security. The attack also brought to light the importance of data integrity. During the chaos, there was a possibility that data might be altered either accidentally or maliciously. How can MedTech ensure the integrity of its data in such a compromised environment? Implementing mechanisms like hash functions and digital signatures can verify data integrity. Hash functions, which generate a unique value from the data, can detect any unauthorized modifications. This practice ensures that the data remains accurate and consistent throughout its life cycle. As the team labored to restore services and secure data, questions about the authenticity of users and systems involved in the network surfaced. Was every user or system on the network genuine, or were there potential intruders masquerading as legitimate entities? The deployment of MFA, digital certificates, and biometric verification was critical in confirming the legitimacy of users and systems, thus reducing the risk of unauthorized access due to compromised credentials. Another critical aspect that MedTech had to address was non-repudiation. With various individuals accessing the system, it was essential to ensure that actions could be definitively traced back to their origin. How can MedTech ensure that the integrity and origin of actions taken during the incident are undeniable? The use of digital signatures and audit logs provided a reliable trail of evidence. Digital signatures offered proof of the origin and integrity of messages or documents, while audit logs recorded system activities, furnishing an indispensable trail of evidence in the event of disputes or security audits. Integrating AI into their cybersecurity defenses also played a significant role. MedTech had employed AI-powered intrusion detection systems that continuously monitored network traffic, identifying suspicious patterns indicative of cyber attacks. How effective are AI-based IDS in detecting and mitigating cyber threats in real time? The AI-based IDS demonstrated high efficacy by achieving a detection accuracy of over 90%, significantly reducing the time required to identify and address threats. Furthermore, AI enhanced authentication mechanisms by analyzing behavioral patterns, such as typing speed and mouse movements, to detect and prevent unauthorized access. However, the use of AI in their cybersecurity framework also presented new challenges. Adversarial attacks on AI systems, where attackers manipulated inputs to deceive the AI, emerged as a potential risk. What strategies can medtech employ to safeguard their AI systems from adversarial attacks? Ensuring the security and reliability of AI models is crucial. Researchers Goodfellow, Bengio, and Corville emphasize the necessity of developing robust AI models resilient to adversarial attacks, which requires ongoing innovation and adaptation. Moreover, the ethical and privacy implications of integrating AI in cybersecurity cannot be overlooked. AI systems require vast amounts of data, which may contain sensitive information. How can medtech balance the need for data access with the obligation to maintain data privacy and ethical use? Ensuring the confidentiality and integrity of data being used by AI systems is paramount. Ethical considerations, such as biases in AI algorithms and the potential for misuse, must be addressed. Developing transparent and accountable AI systems is essential to maintaining public trust and ensuring ethical technology use. Following the attack, medtech conducted a thorough review and reinforced its cybersecurity measures. The importance of understanding and implementing the core principles of cybersecurity became more apparent. These principles, confidentiality, integrity, availability, authenticity, and non-repudiation, were not just theoretical concepts but practical guidelines essential for safeguarding information systems. The solutions identified through this case study illustrate the critical role these principles play in creating a resilient security posture. Encryption and access controls are vital for protecting confidentiality, while hash functions and digital signatures ensure data integrity. Redundancy and load balancing are key strategies for maintaining availability, especially during DOS attacks. Multi-factor authentication and digital certificates verify authenticity, and digital signatures, along with audit logs, establish non-repudiation, ensuring accountability and trust in digital transactions. The integration of AI in medtech's cybersecurity framework enhanced the application of these principles. AI algorithms analyzed vast amounts of data to detect anomalies, predict potential threats, and automate responses, improving the efficiency and effectiveness of cybersecurity measures. AI-powered IDS and advanced authentication mechanisms demonstrated significant potential in enhancing threat detection and user verification. Nevertheless, the implementation of AI also introduced new challenges. Ensuring the security and reliability of AI models against adversarial attacks required continuous innovation. Addressing ethical and privacy concerns related to AI's data requirements was crucial to maintaining public trust. In conclusion, medtech's experience underscores the importance of a comprehensive approach to cybersecurity. By understanding and applying the core principles of cybersecurity, organizations not only protect their information assets, but also establish a foundation for integrating advanced technologies like AI. This creates a resilient security posture, capable of adapting to evolving threats and safeguarding critical information in an increasingly digital world. The lessons learned from this case study highlight the interconnectedness of these principles and the need for a balanced approach to ensure robust cybersecurity.